Hello everyone, and thank you for joining us for another tutorial in developing games using C# console. In this tutorial, we're going to review our previous game Tic Tac Toe of the Absolute Beginners playlist. In this session, we're going to talk about how to extend the game to be generic and fit any in a row, for example 5 in a row. We will do a quick review on what's wrong with the current Tic Tac Toe game and then look into how to refactor our code. While we do this, let's take a look at a deep dive into taking big problems and breaking them down into smaller chunks so that you can handle it and it doesn't look too daunting and overwhelming. So let's get started. So here we have our Tic Tac Toe game, and let's do a quick review so we know exactly where we left off and how far we've developed the game. As you can see, we've run the game, and first thing we do is we give the user some instructions and information about how and what to do. Then we draw up the board, and then here the user gets to make a selection to which value they want to modify. So if we go ahead and stop this, let's now quickly review the code. So the first thing we do is we create a variable that has the game status. Then we have the current player that's going to be taking a turn. And then we have the game markers that's going to display the columns and rows where the values and the user is going to interact with. So then we have a do while, and this is the main logic as it's going to continue to loop. Based on the game status, we decide whether we should continue the game or exit the game. Now, if we exit the game, we clear the console. Then we do a heads-up display and then draw the game board. Now, the heads-up display, as we mentioned, is the information that we give to the user so that they can decide on what to do in the next move that they're going to make. In this case, if the game is ended, we do display the current player. Then we are going to draw the game board. The game board is drawn out using console.writeLine using the game markers, where the user placed X's and O's. Then after that, we decide if the game status is equal to 1. If it is, then we can say the current player won. And if it is not, and if it is 2, then the game is a draw. Now, if the game status is equal to 0, then we continue looping. We do the same exact thing as we did here. We continue to clear the console. We get the next player that's going to have a turn. Then we do the same thing where we display the heads up and the game and draw the game board. Then we go into the game console, and then based on the marker that the user made, we check to see if there was a winner, and the game status gets updated, and if it is not, then we continue to loop again. Now to go to the game engine, in the game engine we do another loop, which is a do while. And this one, we decide to see if the user made a valid move. Now, we do take the game markers and the current player. So we ask the user for their input. Then we check to see if it is a valid input. If it is null or empty, then we continue looping until the user gives us the correct information. Then it has to be 1 through 9 values, and then we convert that and get a placement marker, and then we check the current char to see if it has X or an O. If it has an X or an O, it's an invalid move. Then we ask the user to make another placement. If the game is a current valid marker, then the player makes a move. Then we update that by getting the player's marker. Then we set the not valid move to false, and then we get out of the loop. So this is basically how the game is set up and how we play the game. Now, what is wrong with this current game? The reason we did this originally, the intent was to display the game and have you learn C# coding. It wasn't so much about the game. The game was just a fun thing to do so that you'd be excited into developing something interesting rather than learning how to read and write to the console. Now, we did this using everything as methods, and it is very specific to the console. We cannot extract this to make this for a UI. And the reason for that is if we go to the game engine, we're actually reading from the console, which binds us to a console application. So if we were to take this into a UI, rather, for example, in Unity or a WinForm UI or some other UI application, you would not be able to do that because you have these console.read lines in here. And also we have console.write lines with the messages. So we have to update this to it is non-dependent to the console, and all this information is outside. Now if we come into the main loop, these console information that we have are okay because they are outside of the game, and these are information that you would display to the current console. Or if it's a WinForm app, then you would decide this information to be placed either on buttons or some other UI that you have. So that would be okay. This is what is wrong with the current game. Let's look at some other aspects of this. If we go down, everything is static, meaning that we made some changes to make this thing to be dynamic, but still we're passing it these values 0 to 1, which is very static. And if we were to extend this into a game that has, let's say, 5 rows and 5 columns, then you would have to come in here and update this. And then you would also have to update these because now you have more markers. The next thing is the game board drawing. It is very static. And again, if we were to extend this game, you would have to come in here and modify this. What we want to do is we want to make this thing to be dynamic so that it can be any columns and any rows, and then any combination in between those columns and rows for in a row winning. So that's pretty much what's wrong with the game. And now we'll go over and how to extend this and looking into how to break this up into smaller pieces. Because to go there and modify this to make it one, to take all the dependencies out, and then two, to make this dynamic would be pretty big undertaking. So what we need to do is go through this one at a time and modify it so that it is manageable. And we just go ahead and update only one method at a time, test our features, and then continue going forward. As noted before, we're now going to refactor our code and get it ready for the changes we want and separate the game logic from presentation. Presentation is our UI console, Windows app, or Unity, maybe something else. This will make it easier for us to introduce the big changes later on. Create a new class, and we'll name ours any in a row game engine. Let's go ahead and make it public. Now, what do we put inside of the game engine? The responsibilities are for it. So just looking at here, we have the game status, and I think the game status should be part of the game engine. And the reason for that is that as we interact with the game engine should know if there is a winner, if there's no winner, if there's any more moves left to do. So let's go ahead and bring that in. So we'll create a property and name it the same exact thing. Game status, except we should make this uppercase. There we go. So now that we have that, what we can do here is create a variable and call it game engine equals any game engine. And then we can set the game status equals to 0. And then delete this. Now every time we need to figure out what to do, we can go in and keep setting the game status for now and update here. Let's see if there's anything else we need to do. It looks like that's pretty much it. Now the check winner, how the game status is being set, is not quite correct. Game status should really be updated inside of the game engine as the player makes a move. We should not have any external ways to update this. So, but we'll keep it as this because we're just introducing small code refactoring to keep the code that we have in working condition for now. And we'll introduce big changes later on as we go. So the next is, what about the current player? So the current player variable is actually associated to our method get next player. So we need to move this as well. Let's go ahead and take that into our method. And let's make this into a public and remove the static value from it. So now we can take the game engine and that should work. Let's make sure that we're not using it anywhere else and doesn't look like it. And now we can take the current player. We can, I guess, keep that in there for now. We can actually move this up. We'll go ahead and remove the var into just explicitly calling the game engine. The var keyword is a easy way to shorten this. During the compile time, it will actually convert it to this game engine object. So for now, to keep things a little bit more clear for us, we'll keep it as it is. So the next thing is the game markers, and the game markers are also responsibility of the game engine, and the game engine should be responsible for having the, basically, because this is the game board, right? So what we need to do is bring that over. So we can come in here and have a property, and it's going to be a char array. We only need the getter part, we don't need the setter. And return this. So now to fix this, because this is a new char array, and this should fix the error. So there we go. So now if we come in here, we've already updated our game marker, so that should be fixed. So now we moved most of these values out to the game engine. And so what else we can remove? So right now we'll keep the clear console there. We are calling the next player, and we get the current player, the heads up display. The DrawGameBoard should work appropriately. And so now we have the game engine, this logic here. Should this be moved as well? Let's do that. And let's go ahead and update this. And now let's go back to I have to make this public and remove the static. And let's change this to make a move. And then let's make this make a move. And we'll keep that there. Now there's still a problem with this make a move, because we still have these console.read lines and console.write lines as well. So we'll keep that as is. So for this one, get player marker. So this method is part of our UI, which is get the player marker. So what we need to do is also bring this over to our game engine. This is not quite the right place to put, but we'll talk about it later on as to why we think that. But for now, let's keep it there, and that should get the game engine going. Let's go ahead and close this out. So now we have the logic of, is the game draw, if the game is a winner, and all of the logic down here. Now these methods, these are UI specific, right? So we'll go ahead and keep that as is. But from here on up to where we check the winner, this should be part of the game, right? And so let's bring that back here. Okay, and then now we have this game engine check winner. Oops, we need to make sure that it's the same. There we go. So now we have a problem with the check winner because it is not public, right? So we have to go check winner, make this public, and let's remove the static value out of that, and that should work. So this is really a quick refactoring and removing the dependencies, although it's not quite 100% what we hoped for this game engine to be as far as the dependencies, because we still have this logic. And then let's do a quick test to make sure it's still functioning. So if we run this and we have 1, and then we have, let's say, 4, and we have 2, and then let's say we have 5, and we have 3. We should have player 1 winning, and it is. So the game is functioning, and with the modification that we did. So now this UI part of it's a little bit more cleaner. And then so now what we're going to do is go and separate out the UI elements that we have in here, and we can talk about how we're going to do that next. So now let's go ahead and figure out what belongs to the make a move and what is dependent on the UI logic. So this while loop from here up to here really should be part of the UI, because the make a move should really be about validating the user's input and placing the mark onto the game marker. So let's go ahead and actually copy this, and what we're going to do is where we're making the, and then let's delete all of this and put these two inside. So it's almost like what we were doing before, except now we are bringing this into the UI. The other thing is the user input really should be also dependent on the UI. So let's bring that over here. So now you have the user input, and we're gonna pass that over to make a move, because the make a move is responsible for validating this user input. So let's go ahead and select the user input, and there should be a string, at least for now. We're just gonna make everything work as before. So now we're gonna go ahead and delete this, and we're gonna remove the while loop. Let's reformat that a little bit. Okay, and then we have this is valid move, and then we also have the console log red lines, and how do we deal with this stuff. So the make a move is not valid because now we need the user input. So let's go ahead and put the user input in there, and this should make this valid. Now we need to figure out the not valid move and what that is. So this game engine should be returning a value if it's a valid move or not, but we also wanted to extract this so that it's no longer dependent on console log write line. So what we can do is create a class, and let's go ahead and for right now create it here, and this is going to be our data structure. We're going to put return back, and let's make this public class, and let's name our class game results, right? So it's going to have a property of a boolean, and it's going to be valid move. We're going to keep the get and set for right now, but we'll come back and fix this. The next thing we want to do is create another property, and this is going to be a string, and now the string is going to be a message that's going to be passed. So what we're going to do is we're going to return these information as part of a message. And what we can also do is create the game markers here as well, but for now we'll go ahead and skip it. We'll come back and fix this properly. We can also take this and move it to its own class. So now we have our own class in there. So we have all the values that we need. And what we can do is, first thing we're going to do is create our game result. This really should be singular, not plural. Let's go ahead and fix that. Game result. Go back here. Let's go ahead and rename this. Yes. Okay, that fixed the naming here as well. So now we have that. Now what we can do is set the game result valid move. And now that we have a valid move, we're going to set this to true. So what about these messages? Well, we're going to take out the console.write lines, right? And we're going to do the game result dot message equals. So now we can have the messages written into this object, and then we're going to return the game results variable. So but now we also need to change this void, because now we're returning a value to the game result. Let's go ahead and change our variable to also be singular. So once we do that, we need to rename everything to the game result. So that's done. There we go. And then now we have the user input, we're passing that, and then what we can do here is set a variable. Okay, there we go, game result. So we set this, and what we can do is, so this is inside the loop, we need to put this outside of the loop. And let's take this out. So now we can say, while this is not a valid move, we continue to loop until we get a valid move. So here, now what happens to those messages? So we had our if else statement here. So what we could do is a quick check if game result not a valid move, and we can do console.write line game result dot message, and then we check to see if there is a winner, and then we continue looping. So it's a similar logic as before, but now we've removed all of the dependencies. So let's go ahead and actually run this and see if it's going to execute and function as it was before. So let's actually put 1, and now let's have our player 2 put a marker in the same place as the player 1. So we got the correct message that it's already got a marker. So let's go ahead and put 4, and then let's put 2. Let's actually just hit enter. So that's invalid. That's correct message. So now let's have 5, and then now 3 for player 1 to win, and we have the correct winner. Okay, so this worked, and now we've totally separated out the UI elements from our game engine and brought everything back to where it's supposed to be, and to the UI. Now in the next section, we're going to talk about how to extend this to be any row, so that it is much more than what we have here, which is everything is static. So we'll do that same as we did here, one at a time. So this was more of a refactoring exercise to figure out what belongs where, and then now we're going to extend the game engine to be able to allow any in a row win. So before we get started, let's go ahead and go over some of the rules. We said that our game board is going to be dynamic. So here we have a game board of 8 positions, going 8 columns and 8 rows. And so, but if this was Tic Tac Toe, it would be 3 and 3 rows, or if it was 4, then we would go up to 4 rows. But here for this example, we're showing 8 by 8, which means that the game will be square and it won't be rectangle, meaning that the columns and rows will match. So you want to have something where it says 10 columns and 5 rows, for example. So for this one to keep it simple, we'll just keep it a square. Then the win in a row must be actually less than the game board. So it means that if the player makes moves, we cannot have, for example, 9 in a row. If this is if there's 8 columns and 8 rows, you cannot have anything greater like 9 for it to be a winning move, because you just don't have the column. Doesn't make any sense. The other thing is that when we're setting this, a user cannot say that our board is less than our tic-tac-toe. So you can't have 2 columns and 2 rows. The first player who makes a move will always win, so that doesn't make any sense. The other thing is that we're going to initialize our game using multi-dimensional arrays. So the way we did our game in here was that this was initialized as an array of chars, and we were lucky because we only have 9, and we'll explain that in a little bit. So when we're initializing our game, so it'll be multi-dimensional, so it's going to have the first array is going to be the columns, and then, or excuse me, the rows, and then the second will be the columns, and we'll take a look at that and see how that's going to work. The game markers will not be X's and O's like we have here. What we're going to actually do is we're going to have the player number. So if it was player 1, we'll mark it as 1. If it was player 2, we'll mark it as 2. The reason for this is that when the game board is passed on to the UI, we allow them to decide whether it should be an X, whether it should be an O, or something else. So we'll let that be an implementation of the UI. The other thing is when we initialize this, in the beginning, everything will be started with zeros. So all of the rows will be 0, like so. Even ones here, so it'll be all zeros. And then how we're gonna validate the winning move here is going to be wherever the user made a move and placing their marker, we're going to check the winning move from that position. So before we used to just go from very top and check horizontally, vertically, and diagonally if there was a winner, and that was pretty simple and easy. We could have done the same thing, except what we're going to do here is do it a little bit differently, so we can see some different exercise of how to do looping and trying to figure this out. Now this, the way we did it before was we just moved forward. Same thing with the columns going downwards, so even diagonals was forward. But here, if a player makes a mark in the middle, we have to then check the next value to see if it's the same, and continue the sequence until n row value is met. If it's not, and there's a break where there's no move in there, or the player has moved, then we go backwards. So horizontally and vertically and diagonally, we'll move forward and backwards, trying to figure that out. So that's pretty much for the rules, and now that we have this, let's go ahead and actually code this and see it in action. So the first thing we should do is go ahead and work on printing the dynamic version of the game board. Kind of like what we did here, but except make this so that it's dynamic based on the board, the game board that we are doing. So if you look at this, we start off with the very first line. We have the column numbers, and we said we're going to keep this. The reason for that is that we're going to ask the user to enter the column and the row where they want a entry. So if they say 1 1, then we would put an entry here, or if they said row 1 column 2, then we would put an entry there. So let's go ahead and actually print this out. We're going to start off our console from, so if we run this, the edge of the console where the cursor is, that is going to be right here. So we're going to go 1 2 3 4 5, and then we're going to start our number, and then we're going to go 1 2 3, and then we're going to start a number, and so forth. So that's the first thing we're going to do. Now, in order to do that, we need to have our game board. Now, unlike the way we did the game board in here by just having a char characters, we're going to create ours a multi-dimensional so that we can have the rows and columns when the user entered it and get that. So let's actually go ahead and comment a few things here so that it'll make it a little bit easier for us to work with. So for right now, we're just going to do this procedural, and we want to make sure that this actually works before we continue. So the first thing is we're going to declare our board. So we're going to say int. And now if we did this, this would be an array, but if we do a comma here, it's going to tell it it's multi-dimensional. The first one is the rows, and the second one is the columns. So we'll call ours board equals to new int. Now if you do this way and we put 4 or 3 or whatever that is, we're just telling it to go 4 rows and go 4 columns. So because we have 8 up there, let's go ahead and do that. So this would be how we can create the this is how we can create our variable. Now if we debug this and run this and look at our board, as you can see now, we have, this is row 0, column 1, and column, this is going to 0, column 0, column 1, column 2, column 3, 4, 5, 6 to 7. Because the arrays are indexed of 0, we're going to have 7, but that's actually 8. And then this is the second row, and on all the way up to the 8th row. So to visualize this, let's go ahead and actually initialize this a little bit differently. Now by doing this, we already initialized everything into zeros because the default initialization of int is a 0. And instead of doing it this way, now let's go ahead and actually do it a little bit differently. We're going to use the object initializers. And in here, let's go ahead and create the first column, and we're going to now initialize everything with zeros. So we're going to have 1, so it's going to be index 0, 1, 2, 3, 4, 5, 6, 7. And so this is row 0, and this is going to be row 1, 2, 3, 4, 5, 6, 7. So this is going to be the same way as we did here, except now you can visualize that this is row 1, or row 0, excuse me, row 1, row 2, 3, 4, and this is the columns. So if we run this, we should have the same variables as we did before. Row 0, column 1, 2, 3, 4, 5, 6, 7, and then row 1, same thing, all the way to the 8th row. So we'll keep ours like this because it's easier to visualize, but when we actually start the game, it's going to be set up this way for us. So what's the first thing we're going to do? We said that we're going to print the numbers. So that'll be easy, right? Because we're just going to create a loop here. And let's keep that as an I, and then we're going to say board. Now we're not going to use the linked. We're going to say get linked, and the get linked is going to tell us what length we want. If we say 0, then it's the rows, and if we say 1, it will be the columns. So we'll just use, because this is a square, it can be either one, so we'll just use 0 for right now. Okay, so now that we have that, we're going to be iterating the correct numbers. So what's the next thing we're going to do? Well, before even looping, we need to set something properly. We need to have these spaces done and then start with the numeric values. So let's copy that and just do a console.write. Now we're not going to say write line, and the reason for that is because we need to write this and then write the next one. If we said write line, it would be something like that, and that's not what we want. Now inside of our for loop, we're going to also have another console.write, and inside of this we're going to print out our integer value from 0 and off. But because we wanted to start it with 1 to not confuse the users, as programmers we will deal with zeros, but as a player it should really be a numeric of 1, 2, 3, 4, 5, 6, 7, 8. So we're just going to do +1, so that way it displays this correctly. So if we did this, it would run everything and have no spaces like we have here by having 3 spaces in there. So how would you do this with having a space? Well, we could do it one way by, let's copy this and let's use our string interpolation, and then say 1, 2, 3, 3 spaces next to that. Actually, let's do 2 spaces and then put a space here. So 3 spaces. Let's run our program. Let's change this to read line. So now we have our values printed properly. What's the next thing we want to do? Well, we want to start the next line and we want to print this out, but this has to be dynamic based on the size of the board. To do that, first thing we have to do is do a console.write line, because at the end of the 8th digit we want a new line, because we're going to then print out the ceiling of the cells. Now after this, what we need to do is we need to print out these ceilings. But before we do that, we have 1, 2, 3 spaces in there. So we need to have these 3 spaces, and then we need to have our first dash. So from here, this is what we need to have. The reason we need to have this is because if you count this, the first dash is 1, 2, 3, 4, and then the 5th one, and then 1, 2, 3, 4, 1, 2, 3, 4, all the way. When we come here, there'll be 4 of them. So we just need to account for the very first one. So let's go ahead and copy that, and now the first thing we're going to do here is going to be another console.write line, and we are going to print everything from here to the first dash. Then we're going to have another loop, except this time we are going to have the 4 dashes, so that will give us the complete ceiling that we're looking for. But there is a better way of doing this, and that is to use the string, and then we're going to use the char value, which is a dash, and then we are going to tell it how many times it should do it. We're going to say 4. So what this will do is it'll create a string with 4 characters of this dash, and then we're going to also have another console.write line, because now we need to go to the next line and print out the 1 as well as the actual cell walls. So let's test this to make sure it's working, and it is. So now we need to be able to have our ceiling walls and the value of the row numbers. To do that, we are going to do another loop, and we're going to say board get length, and we'll just use 0 for now. So this should be enough to give us each rows. So the very first thing we want to do is print out our numbers, right? So it's going to have a space and then the number and then a space, and then it's going to have the cell wall to it. So we're going to have it this way. Now we could just do this as well, do +1. So if we run this, we have our numbers going downwards. What we need to do is between the 1, we need to have the ceiling as well again. So we can't really do this using console.write line. We just have to say console.write. The next thing we need to do, once we print this out, we need to loop through and get the ceiling walls. So for that, we need to do another loop, and let's call this one J. And this is also going to be based on the board get linked. And then in this one, we're going to say console.write. But we're going to have a pipe and then 1, 2, 3. And then when this is done, we're going to do a console.write line so that we can go to the next line. And then we need to do exactly the same thing for printing out the dashes. Basically, we need this piece of code over here. So for now, let's just go with copy it and print it, and then come back later. We're going to fix it. And let's make this one K. And let's see how this is going to work for us. There we go. So everything worked except we didn't get our last dash in here. And the reason for that is that we need to do an additional, we need to have not 8, but we need to have +1. And the reason for that is, like, if you count this as 1, 2, 3, 4, 5, 6, 7, 8, we need to have an additional 1. So to do that, we need to put a +1 here. Now if we run it, we will have the correct values. So far it looks good. And if we initialize our board to be 3 or any other value, this will print out properly. There's a couple of things that we haven't gone over. Well, how do you actually print the value inside of this? What happens when these columns and rows go over 10? That's going to be an issue here. For now, let's just keep it under 9, and then later we'll come back and fix that. So the next thing we need to do is we need to look at this and say, what else can we do to improve this? Because if you look at this, there's a pattern. We have a console.write, and then we have a loop, and then we have a console.write line. Then we go back to starting a console.write, and we have a loop, and then a console.write line. And this pattern repeats here, and we're actually duplicating code from up above over here. So how can we make this so it'll be shorter and much more cleaner? One way to do that is maybe we can create a new method, and let's call this one print console. For right now, we'll just keep the name print console, but let's actually return void for now. And what we're going to do is copy this, because this is the pattern, right? And print this out here. So we're going to need the board, right? The length of it. So we need to have an integer. That's going to be our loop counter. So that's going to be this. And then we have this space being passed in. So we're going to say this is going to be a string. And the string is going to, we're going to name it print digit. Okay. And then take that and replace this code. And then what about this piece over here? How can we make this work? Well, we can have another string here, because this is multiple strings being printed out. Maybe we can call this one string print digits, right? And what we can do is have that printed this way, right? And then now what we can do is comment this line and instead call our print console method, passing the loop counter, which is going to be this one, right? And then what we need to do is pass in the digits we want to be printing as the first one, which is basically spaces. And then the second part that we need to do is going to be the print digits over here, this value over here, right, which is going to be an integer value. And how are we going to pass this to have this as a +1? Well, one way we could do it is to have another value here called increment print digits, and this should be an int. Okay, so that way you can tell it how many times what this number should be. So let's actually keep this empty for right now, and then here we're just going to say 1 because we're just adding 1 to this counter over here, right? So let's make this static. There we go. Now, what about this formatting? How can we fix the formatting? Well, we can fix the formatting by passing this, right? Now you're probably wondering why we're doing that. There is a way to, so when you're doing, let's say, console.writeLine, and we've gone over this in our previous tutorials, when you can say, you can have some values here, but then you want to add something dynamic in here, right? And then here you can come in and you can say 1. What's going to happen is that now you're expecting a arguments that the console.writeLine is going to look at this argument and it's going to stuff it into this, right? So if we just did that now, notice now you get the 1 in here. So if you had multiple arguments, so then what you can do is, no, this should be inside of the quotes, and then you can say 1. So this is the first argument and this is the second argument, right? And let's actually call this one 2, so that let's separate this by pipe and run this. So now you got the first argument and the second argument. So that's how you can pass arguments and stuff it to a string using a formatter. So that's how we can pass this in, and it will add that in there. But what we need to do is we need to put the spaces after it, right? So now let's run this to see if we're going to have the same format, because now we comment this thing out. So if we run this, things are not coming out correctly, and there being too many spaces. What we're doing here, okay, so, okay, what we forgot is that we need to pass that argument is going to be I, right? I is going to be plus increment digits. Okay, so we run this. So now we have the digits, but they're not being spaced correctly. So 1, 2, we need to have 3 spaces in there, not 1. So just put an additional 1. Let's run this. Let's run it again. Okay, so now it's showing things correctly. So now we don't have to have this piece of code in here, right? We'll just keep this for right now, but let's go ahead and do the same thing for this guy here. Let's comment that guy out. So we do need the board length to be the same, right? The first digit that we're passing it is going to be that. the second digit is going to be this, and here it doesn't matter what we pass because we don't care, and the reason we don't care is because this string that we're passing doesn't have this parameter in it. So when our C# console sees this, even though we have this in here that we're passing as an argument, it doesn't find a formatter for it, and therefore it will ignore it and will not print anything. So now that we have this piece, we should have most of this working in functional. So let's run that, and there we go. So now we're having all of the ceilings done correctly. Now let's take this again and comment this guy. Okay, so now we have our loop counter, which is going to be what we're passing here. But this loop counter is +1, right? So initially do that, do +1. And then, except what we're doing now is we're going to be passing our formatter like we did up here, right? So let's copy everything here, except this is going to be our formatter, and actually we don't need to pass anything here. Actually, we don't even need a formatter, we just need a space. This is where we put the user's marker, right, where player 1 or player 2 made a move. For now, we're just going to keep the board as is. And then let's do the same thing for this. Let's copy that. So now we're going to have the same length, except this is going to be that. Oh, so what we need to do is we need to copy this piece here because that's the same exact code, right? So we don't have to reinvent the wheel here. There we go. So the only thing that's different is just this one loop and then a bunch of print console methods that are being called, right? So let's go ahead and close this and run this again. So things are not coming out correctly, right? And the reason things are not coming in correctly is because we didn't put the pipe properly in here. And that's what should have gone inside of this. And if we run it again, and except now we're having this dash instead of the number printed. So the reason for that is because this should be the values that we want to increment, right? This value here that we wanted to call. So what we can do is copy that, or actually just uncomment this, right? Because that's still the same. And then except for this one, and it does. So now we've got everything correctly printed out. That's pretty much our code now. Let's go ahead and clean some of this stuff up so it can make it a little bit easier to see what's going on. Okay, so that's pretty much all you need now in these lines of code to have this printed out. Now there is one thing that's missing here, and that is the value that we're going to pass, where we're gonna put in the user's marker in here. But we'll do that later. So for now, this should be good. And now what we can do is keep this method. Let's take this one to the bottom, right after the DrawBoard. And then take this code. Actually, let's cut this. Let's comment this out. We need to change this game marker to the int, right? And change this to the board. So now all we have to do is just say DrawBoard, passing board. And there we go. and that should work. Now let's go ahead and comment this out so we can test some things. And let's make this 3, and that shows correctly. But what if we say we wanted to have 5 columns? Although I know we're not doing this, but let's see if the game, the way we wrote it, is going to allow for this to actually function. And it doesn't. The reason it doesn't do that is because if we look over here, we're actually telling the get length we're using the rows, and if we were to use the columns instead, so now things might change a little bit. So let's take a look at that. So now we have our 5 values, but not the board being drawn out, right? And that's because this also needs to be columns, and then this is going to be rows, and these are going to be columns. Right? So now if we run this, our board actually prints out the board correctly, regardless of the columns and rows. So we now made a very dynamic game board. Now, of course, we're not going to worry about this. We're going to keep this as is. So now it's going to go back to the way it was before. There is one issue with this, and that is when we said if we go to more than 2 digits or 3 digits. So if we go 10, 10, then what's going to happen is that our board is going to have this kind of issue where now we need to account that if we have 2 digits, then we cannot put a space here, right? So that everything gets shifted back this way. But then what happens if you had 3 digits, like maybe if this was 100? Well, you would run into a problem, and that problem is going to be the console itself. The buffer of the console is not going to look correctly. Even if we maximize this, it's going to look a little bit off, right? Because it's going to wrap around basically. So if we go up here, notice that, well, let's just stop this and let's run this again. There we go. So what happens is that we get everything here, comes up to the 60, and then gets wrapped around, and this is how it's going to show. Now, of course, my monitor is a little bit bigger. Yours might show something a little bit differently. So what we're going to do is keep the board up to 60, nothing more based on my screen size, right? Or you can change this to be default no greater than 20, for example, right? So that way it would work. But for right now, for us, we're just going to keep everything, we're going to keep it as 8. 8's a good number so that it shows everything correctly. We will show you how to fix that properly next time. So the next thing we need to do is make this so that it's dynamic, that the user enters the board size and in a row winning a move. So, you know, if we have a board of 8 and they say 5 in a row, we need to have that so that we can send it to the game engine and have the game engine be aware of it as the players make move. Now, before we get started, I want to kind of go back and look at this code that we had over here where we have this console outright line, and after looking at it, I don't think it's quite in the right place, and what we should be doing is actually copy this, or actually let's just copy that for right now and then comment this line of code and go back to our print console on the very first one where we had the empty line. Instead of having the empty line, let's just go ahead and put that in there, because this makes more sense of it being there rather than being outside, because the pattern that we were looking at was to have a console outright line, a loop iteration, and then a console outright line, right? So this way we are maintaining the pattern. So let's just quickly test this. And as you can see, it's printing everything correctly. So let's just keep that there for now and go ahead and close that out. Now that it's working, we can actually remove this line of code. And since this is also working, let's actually remove these lines of codes or comments as well in the code. Now let's go back up here. Now what we could do is actually have console outright lines and read lines to instruct the user on what to do. But instead what we like to do is because we're testing this, and we'll leave that up to you. For right now, we're just going to create variables to hold this number so we can quickly change it and test it for our purposes. So let's just create one, and this is going to be our board game size. And let's make this 8, right? And then we'll create another int, and this is going to be our win in a row. And let's keep this as 5 for right now. Okay, and then what we need to do is need to pass these values over to our game engine, which is down here. So we need to, how do we set this? Well, we can pass it through the constructor, and then from the constructor we can set those values, and then when we're actually using the game engine, it'll apply everything that we have up here. So the first thing we have to do is let's go to our the constructor. Well, there is no constructor here, so let's go ahead and create that. So we have our default constructor, and this one we're going to create a int game board rows. Let's just keep this as rows, and then have another one game board columns. Now we said ours is going to be square, so what we're doing right here is we're imagining that maybe there will be a change in the future that's going to have the board size not be square, be rectangle, and so if there's going to be a rectangle, we need to have those values. Even though we're working in a square rule of the game board, so this should give us some idea later on. It'll make it easier to implement changes, so we're kind of foreseeing what may come in the future. And if there's no change, it's still going to work. It's not going to hurt it, right? So the next one we're going to pass is going to be the int win in a row. So now that we have that, the next thing we need to do is take these values and store it so that the game has the values in here. So for our win in a row, so what we need to do is we need to create some private variables, and this one is going to be our int game board, right? So it will be game board, and then we're going to create another one. This is going to be our private int win in a row, for example, win in a row. There we go. So now what we need to do is set these values. Now before we set these values, what we need to do is we need to make sure to do some validation. And this validation is really to make sure that this win in a row is not greater than our game board size, because then the logic cannot be applied properly and there will be no winning moves in certain scenarios, right? So let's create a validation method here. So let's actually put this in here. So we're going to say something like validate when in a row, and we're going to pass it the same values that we have, and let's take out the ints, right? So here we're going to have Visual Studio help us with that by generating that method. And then after this, what we need to do is initialize the win in a row. But for now, let's go ahead and wait and finish the validation. So what is the validation going to do for us? In the validation, what we need to do is we need to take account for the rows and columns. So what we need to do is figure out the minimum size between rows and columns. So let's go ahead and create a int min board size. And we can do this by using a class called mat, right? And then it's going to have a min. So it's going to take two values and figure out the minimum and then pass that along, and now we have that. So once we have this, we can then just do a quick if to see if the min board size is less than win in a row. If it is, we need to throw an exception. And what type of exception we want? We can say exception, just a general exception, but because this is a argument exception, we can just now use the argument exception class and pass that as a as the exception. And we're going to say when and a row value, and that value is going to be when in a row is greater than board size. So now why we throw an exception? The reason is that when we come into the game and we're initializing this game board object, we want to have the exception so that the program halts, so that we can't go any further. Because if we didn't have to throw the exception, then we would continue with the loops and some of this stuff would not work properly. So that's why we need to throw these exceptions. Then the next thing we're going to do is we also said that if the game size it should be no less than our Tic Tac Toe, right? So then we're going to say min board size is less than, let's say 3, right? Because that was going to be our size of our Tic Tac Toe. Then we're going to throw the same exception, but this time we're going to change the values to say the board size, and this should be the minimum board size, must be greater than 3, right? And then the last thing we want to do is very similar to what we did here. So let's just copy that. And now we're going to say that our win in a row must be greater than 3, right? Because that's the minimum. So now we're going to say our win in a row must be greater than 3. So that's the validation that happened here. And then the next thing we can do is initializing the game board. And that is to set this value in here. Now, if you're just doing it and expecting to fill in the game board with zeros, all we have to do is just say game board equals to new int and set the columns and rows, right? That's pretty much all we have to do. But if you wanted to change it so that the initialization would be like, let's say -1 or some other value in here, then what would you do is you can create another method. And so we can actually let's comment this guy out for now. So in here we can create a new init game board, and in here we're going to pass it our game board rows and our game board columns. And let's go ahead and have Visual Studio help us with this method. And then we can go through and initializing initializing this game board. Now you can grab this as is. Right, so first we initialize our value, and then what we're going to do is do a loop, and then we're going to do another loop, and this one we're going to call, let's say, J. Right, and this will be game board columns, and then we're going to initialize this to something. So for right now we'll just go for 0, and let's actually put curly braces, but this can be, let's say, -1 if you wanted it, but let's just create it as 0. Although we're duplicating the work here, it's okay. This should just give you an idea of how you would go around doing this. To make the variables a little bit more readable, we can actually call this row. And let's go ahead and have Visual Studio help us with renaming that to row. And then we can actually call this call for columns. There we go. So now it makes sense, but we can also do get linked. Well, we will have to do the game board, so we can do game board get linked, and because we're dealing with rows, we'll go to 0, and we could also change this to say it will be 1. The other way we had it also would work, so we're just showing you multiple ways of setting this up, so we leave that up to you and how you want to do it, but this should work. So we'll keep this for now to give you some ideas of how you can initialize this. Now that that's been done, when we come in here and we want to set this up, so we can just say the board game size, and you can say board game size, and we're going to pass the same value, which is fine, and then we're going to pass the when row, and everything should work just fine, right? So let's actually comment this out. Now if we run this, it should throw no exceptions, everything should work, and we'll just come into our read line. But what happens, let's actually comment this out as well. Now what happens if we go and say our winner row is 2, we should throw in exceptions, and we do, and if we continue, then we see that exception being thrown that says winner row 8 must be greater than 3. So this is not coming out correctly. This actually should be okay, so when we threw in, we got the board size, right? So this should be win in a row. There we go. So now we threw the exception, and now it says win in a row is 2 must be greater than 3. So that's working. And let's keep this to 5 again, and let's make this to be 2, and now we should have another exception thrown, which we do. And if we go look, win in a row value 5 is greater than the board size, which makes sense, right? Because we should not have our win in a row and having 2 as the game board. Okay, let's Control Z, leave that as is. Okay, so we have that now. That's great. We got the rules set up properly. Next thing we need to do is now go and make modification to our AnyGameRow engine to start making the rest of this code work correctly. So now let's go ahead and uncomment the code and see where we have to make changes so that the code or the game logic functions properly. So let's go ahead and uncomment all of this. And now immediately we have some issues with getting the next player and what the current player is. And if we go here and uncomment that, that'll resolve it. So by uncommenting the current player, the heads-up display works, but the DrawGameBoard expects the game markers, which is not working. And the reason it's not working is because if we go to, well, first of all, this is char, and the game marker is also char, so that's not going to work. What we need to do is convert this so that it is an int. So let's go ahead and go to our game engine. So the first thing is the game markers, and actually let's change this to be game board. And we're not going to make this an array of chars, we're going to make it an int. And what we're going to do is return the game board. So that still leaves us an issue. We can actually remark that out and go here and set our game engine as the game markers. Now we have a game board instead. We don't have that value, so that actually works. The next thing is the make move. It expects the game board. Let's go ahead and fix that. Same here. And same here. So most of these will work, except when we're making a move. It's not working because it's expecting a char and we are having an int. So let's fix this, and let's go make this into an int. And let's make this into a game board. And immediately we have some errors over here. And this is going to fail because it's expecting a multi-dimensional array. So here, when the user is passing their input, it really should be int user input row and int user input. So this way we can take the row, and we don't need to do this here, and this should be an int, and now we are getting the user's row and user's column issue. And then same thing for getting the get player marker. Now we said that the get player marker, which is this here, this is more of a UI aspect of it, so we're not gonna do anything with this. We're gonna put that on the UI part. We'll figure this out. Looks like we have some spelling errors here. Let's fix those. So the next thing is this big if statement is failing. So what is happening is that it's expecting these to be integer value. So this string is null or empty is not going to work. So what we need to do is check to see if the user input row and input column is within the game board row and column size. So to do that, let's do a quick if statement here. I'm going to rewrite that to say if the user input row is less than the game board dot get length, because we're checking rows, we're going to do 0, and we're going to check the user's input column, game board dot get length, and this should be 1. So that's basically the replacement for this. Let's go ahead and now comment this and add this to our. Okay, so this piece is working, but we still need to have some other logic inside of this. We just want to make sure that this is not failing the compilation. So let's save that. Let's go back here. So make a move. Now we're going to need the user input row and another one for user input column. So here we would be reading two values. This will be user input row, column, but these are not strings, so let's actually convert these to int. And then we can do convert to int32 and do the same thing here. Now of course you would have to put additional logic to make this work, but for right now let's just make this so that it's functional. And then on the check winner, if we go here, this should be int, and this should be game board, and of course the check winner also is going to fail, so let's fix that. And check this game board. Now these are gonna of course not work, so we're gonna comment that out for now, and then we'll come back and fix it. And then of course this is not gonna work either, because it's expecting the correct value here, so we're gonna actually comment this out as well. We'll come back and fix this, but right now let's just return false. These are not being used. We'll come back and fix those, and then this can go into the UI part. So let's comment this out as well. So now we have a compilable code, although it doesn't work. Now that we have everything compiled, now that everything is compiling, our next step is to put in logic to where we're going to have the game validate and run some rules on if it's a winning move or if it's a draw or anything else. So now the next thing we need to work on is the finishing of the game by putting rules that will check the winning move, going horizontally, vertically, and diagonally. And then that'll fix the check winner. And then let's also update the make a move so that it's fixed up. Something to note here is also that the game board that we're passing and the current player that we are passing, these are probably not necessary, but because this is from the previous game, we'll keep it. Plus it makes it a little easier to update this by when we're testing. We can actually create our own board and pass it to see if the rules will work. So that's why we're going to keep it, but you can, when you're doing your modifications, you could remove this because the game engine should already have a game board internally, and it should only update when the user inserts the values. These should not be passed in. So anyway, let's go ahead to the make a move, and let's delete this because we don't need this anymore. We have the logic already over here. The other thing is that we said that the player's markers are UI specific, right? And so when we go in here, when we're initializing the board, when we initialize to 0, meaning that no move has been made, if the user comes in and says, give me a marker or value that I'm inserting for player 1, let's say, and they choose row 0, the index row 0 and index column 1, or over here when we send, column 1, row 1, they would come in here and we would just put a 1. And then if player 2 comes in and they decide to put a marker there, then we would put 2, and then player 1 and player 2 and so on. So this is how we would put these values in there. So it's not going to be the X's and O's. So we'll have to go in here and update this to say if this is equals to 1 and if this is equals to 2, then the value is not valid because these are not current valid move. So let's also delete this because we don't need that anymore. So now we need to fix this so that based on the current player, we would do an update to the game board where the values were. So the current player is an integer value, and this should actually be this game board here. So let's go update that. So based on the row and column, we would insert a 1 in there, and we'll call it a valid move, and then continue. Then we would exit the make a move by passing the game results, that there was a valid move, and if it was not, then the error message could be displayed. So that makes this thing functional. Now let's go to check winner. Again, in this one we can omit the passing of the game board, but for testing purposes and having this from previous game, we can keep that in there. So let's go in there now. So this is okay. We check in to see if is there a winner, and we're checking to see if the game is a draw, and then we do return 2. Now if the game is a draw, basically we check to see if there's any 0 values remain within our array. If there is no 0 value, meaning that all the initialization values have a player 1 or player 2 in it, then and there's no winning, then it must be a draw. So how do we test this? Well, we can do what we're going to create 2 for loops, and then it'll be for the row, and we could just do GameBoard.getLength. And call GameBoard getLength of 1. And then we would do a quick check if GameBoard current row and current column dot equals to, if it's equal to 0, then we can break out. So then we just do return as game a draw, it would be a false, right? But if we reach here, that means that there were no zeros, so therefore we will return true. So that will work for as game draw. So this is fixed. Now the check winner, this is where most of the logic will come in, so none of this will apply anymore. We can delete these. So here we're going to need 4 methods, and that's going to be is horizontal cells same, and we need also the vertical, and then we're going to need the diagonal, but this is going to be left to right, and we're going to need right to left. So let's go ahead and write these methods out. So let's go to this one first. Now we're checking the horizontal cells to be the same. What we're going to do is, depending on where the user placed a marker, we're going to check going this way and going backwards, depending once we reach 5 in a row. So to do that, we would need to break this down. So we're not going to write the function. We just need to break down to see what the smallest unit of work is going to be. And it's going to be validating these two cells, right? So you get the current cell and then the next cell. So what we would start off with is we need the current cell, and we can get that by the row and column. So if we do an int, because the value of the game board is going to be an int, so we do current cell equals game board. So that's going to give us the current cell. If we want the next cell, then we would have to create a for loop that's going to be based on the game board length. And since this is looking at horizontal, this is actually for the cells, right? So we're going to go down this way using the get length 1. And now if we get the next cell, so this will be in next cell, but it's going to be, so this is going to stay static because this is our row. So that's going to be the same row, but we want the column to be incremented. So we would want I for this, but we want to start this from current column is, and that's going to give us our next cell. Then in here, we would do a compare between the next cell and current cell. So if the current cell equals next cell and not current cell equals 0. So we want to make sure that that is not the same. So once this condition is met, we can start counting. So what we want to do is, so let's say we have an X here, an X here, an X here, X here, and X here. So when you're comparing these two, we want to remember that we have 1, then 2, then 3, and then 4. So if we're comparing the first cell, we need to have 4 more cells to be consecutive for that to be valid. So then we need another value that's basically going to be our n in a row win. I'm going to start it off with 0. And so when we have that, we can then say increment this as 1. Next, we want to do a continue. Otherwise, if we have something that does not match, we want to break. So this first condition is going to get us all the forward ones. But let's say that we had this. So we reached here and now there is no condition there. And let's say now we do have a condition here. So we started here, so we now have to go backwards. To go backwards, we would need something very similar. But first, we need to check to see if our in a row win is equal to 4. This should be, now the reason it's 4 is we want the next consecutive cells, right? Because we're not keeping track of the current cell. It's the next cell and the next cell and the next cell. So if we go here, so if we're comparing this, that's 1. And then if you do this and this, that's 2. This and this will be 3. But then this and this will be 4. So then we're going to do the same loop, except this loop is going to be reversed, right? Because now we need to go backwards. So then we're going to get the previous cell, and then we check the current cell and the previous cell to be the same, and then we count, and then we continue or we break. Then here we're going to say return true. Otherwise, if we reach here, we return false. So we could just make this a little bit easier. So we could just say if this is less than 4, we go in to the loop. If we're winning, we're checking this, we can check for this value. But here we want to look for our win in a row -1. Now this value should be up here, our win in a row. So we need to update our one in a row. The other thing is these are static, so let's just remove that from it to be not static. So there you go, now that works. So if user puts 5, we just do -1 to be 4. Now we're going to be using this quite often. So what we need to do is move this to its own method, and we're going to call this when in a row. Let's apply that. So this way we can use this in other areas of the code. The next thing we're going to do is notice that we are actually reusing this piece of code quite often, so as well as getting the previous cell as well, although this one is getting the next cell, but it is a cell that's being retrieved by the values being passed to it. So what we can do is create a method that's going to validate the board cells, and what we need for that is int our board. Let's make this return false for now. So the next one we need is the current row. Then we need an int current column. Then we need an int compare row, an int compare column, and then we do a ref int for next in a row. So now that we have that, what we can do is copy this piece of code and put that in here. But what we can do is make this to be current cell. So that would be the board, and that's going to be current row and current cell, current call. So current cell, and now we need the compare cell, right? So you could actually create a new int and compare cell equals to the same thing, except these will be compare row, compare column, and then the current cell, that will work. And then for next in a row, we're just going to increment that. That's why we pass as a ref, so it can be sent back. We don't need to continue, and we would just return true and then return false here. So now how would we use this is we go up here where we're doing the if condition. So if we don't need this, we just do a continue. So now we're going to pass it the game board, and we're going to pass it the row, we're going to pass it the column, and then now we need to pass so that we would pass the compare row, so it'll be the same row, because our row is not going to get modified. Then we pass I as the compare column, and then the inner row win. But this is ref, so there we go. And then now we can take this, comment this, and do the same thing, except we're not going to need this guy, and we don't need the current cell, and we don't need this. Let's go ahead and delete this piece of code. There we go. Something else you'll notice is that we actually have this loop and this loop doing exactly the same thing, except this is going forward and this is going backwards. Could you make this into be one loop so that you can take advantage of rewriting only one method for this? You can. But for right now, we're going to keep it exactly like this to make it a little bit easier and not make it any more complicated. So that's pretty much all we're going to be doing for the rest of these. So like, for example, if we're doing diagonals, or we're doing from the vertical cells going from here down versus going this way. So this was the same row, but if you're going down, it's the same cell. So the only difference is that this is from the column, this would be a row, right? Because the cell would be what is going to be static rather than the other way around. So we could just copy this piece of code and go here, and so this will be row. So this will be passing the row. So let's go ahead and test this. Now to test this, let's make this public for now, real quick. And we can go in here. Okay, so and then we're gonna create a boolean. So if we were passing it something like this, where we have 1 1 1 1 1, then it's going to be our board going in, right? And then we want to pick the position where this is going to be the row. So the row is going to be 0. And then what about the column? So the column is 0 1 2 3. So it's going to be the third one. So if we did everything correctly, this should return true, because we would have the sequence going in and meeting the 4. If we run this, and we have false. So let's go here and see what we messed up. So what's happening is that our compare column is the same, so therefore we're counting it the same. So what it should be is that this should be +1. So let's retest this, and the result is true. So what would happen if we pass number 4? Meaning that now we're going to validate from this one, so we can actually go backwards. So let's go back in here and put our breakpoint so that we can actually see this in action. Let's move this back up. So there we go. And we should have our winner row only 3. So now we're going to go backwards. And winner row is going to be 4. So it looks like we may have the same issue as before. So let's continue with this. That should actually... So it looks like there's an issue with our loop in here, which means that since we are going with the column, we should be starting from the current column, not the game board length, right? So we're going to start from the same column, -1, and this one is going to be our game board length. No, this will be 0. So let's try this again. So there we go. Now it's 4 and next in a row. And we came back as true. We're going to do one more test, and we're going to do these as 1. So we have 1, 2, 3, 4, 5. The rest of these will be 0. And this time we're going to check from position 0 to 0. I'm going to start from this position moving forward. So that should be true. Just remove this. That is true. Now we're going to start with column 1. This should also be true, and it is. So this code is functioning properly. What we need to do is test to make sure this is functioning properly, because we had some issues here. So let's see if that is going to work. So let's make this public, and let's make this to private. Let's make it 0 to 0. Let's make all of these 0. So we have 1, 2, 3, 4, 5. Okay, let's go here. So this is going to be our columns. And we said that if this was, this is going to be our rows. So our row is going to be +1. And then here it's going to be our row -1, and this should be 0. And I believe that should work for us. Except what we want to do is this one is going to be our column, and this one is going to be I, because we're going to go to the previous. So the same thing here, column, and this will be an I. Okay, so let's actually put a breakpoint here and test this. So we have 1, 2, 3, 4. Now we break, and this should return true, and we have true. So to validate this now from position 1, or maybe even position 2, because we want to start going forward, and then from here then go backwards, right? Because this is column 0, these are the rows. So now if you run this, we got 1, we should have 2, and now we should have 2 more, and 1 more, and there we go, we should have true. So now what we need to do is do the diagonals. Diagonals will be the same actual code, except they're going to go from here, going down this way, and going back up. So both the row and the column will be incremented. Okay, so let's go back to our method, and we're going to copy the same piece of code. And since we are going from the left side of the board to the right, by incrementing both the cell and the row, we will update our diagonal left to right. Now we said that we're going to update both the row and column, so we're going to need another variable, so we'll use j. So j is going to be equal to column plus 1, and it's going to be almost the same thing. And then we're going to say this is j. So if the j is the column, then I is the row. We're also going to increment that. And what we're going to do now is we're going to, for the column, we're going to pass j. And then for the row, we're going to pass the I, which is good. And then for going backwards, we will do the same exact thing. So we will do j equals to col minus 1, and this will be j, and then we're going to decrement j minus. So this should set us up correctly. So here we have our values starting from this is row 1, 2, 3, 4, actually 0, 1, 2, 3, so that will be row 3, and the column will be 0, 1, 2, 3. So if we did everything correctly, this should return true. So let's go take a look at why this is returning false. Because it is going to is vertical the same. So let's make this private, and then make this public. Now if we execute this, it should return true. It does. And if we go 4, so we can also go backwards and rerun this, it should also return true. Okay, so this time it returned false. Let's go take a look and see what's happening. So for this one, we should get 1, 2, 3, and then we should skip and then go to our reverse. So both, okay, so we should be passing j here. There we go. And now we get 4, and we should be returning true. So this works, and now if we copy this piece of code and go over to now going the opposite, from the right side going to the left side, going this way, and then going diagonal that way. So that means that our row, if we starting from here, our rows are incrementing, but our columns are decrementing. But if we're going upwards, our rows are incrementing or decrementing, but our columns are incrementing. So the first one, we're going to be going backwards, so that's going to be, rows going to be incrementing, that's fine, but the columns going to be decrementing. So our column is going to be -1, and this will be minus, and I believe this should be j is equal to 0. Actually, it should be greater than 0. And then this is going to be the opposite. So the row is going to be -1, but the column is going to be +1. And we're going to be going plus, and our j is going to be to the game board right. There we go. So now let's go ahead and set this up. Let's go ahead and run this. So now we're gonna go, so let's go from 7 to 7, or actually row 0, and the column is 7, so that we can come backwards, so this should return true. Okay, let's take a look and see why this returned false. Because we need to make this private and make this public. And let's copy this. Let's stop our code. There we go. Let's run this now. And that became true. And now let's start from row 2. And so 0, 1, 2, 3, 4, 5. This should go forward and backwards, and that should return true. And it does. So that's pretty much how you do the methods. Now that we know that the methods are working, let's go ahead and make these private. And now when we call is game winner, it's going to call our methods and check the current row and the next or previous, and return true if it found in a row win. If not, it would return false. So to finish the game, we made some updates to the code, and we're going to go ahead and show you that in a minute. So basically the game is now fully functional. So if we start the game is going to ask you for the board size. So let's actually keep it 15. Actually make it 12. And then the next one is what is the win in a row, and let's just say 5 for now, and hit enter. So now we get our board drawn dynamically. Now we've seen this before, but there was some issues, right? Because if the so remember here we now have 1, 2 spaces. We have the first digit and then 2 spaces. Now when it comes to 10 digits, we have to have only 1 space, otherwise everything would be skewed. Same thing with these markers up on the column numbers. So once it hits 10, because these are all in the center, right? So if it's 10, then it would be in here and here. So it kind of look a little bit weird. We decided to make this to start from the first one to here. So even if we went up to 100, it would actually still be in the representing the column that it's going to be. So that's pretty much it. And then the other thing is that when you now enter a row number, so we'll pick row 1 and hit enter, it's going to ask you for the column. So because it's Pellier 1, so let's also choose the column 1, because we want the X to be in here. So if we hit 1 again and then enter, and now we get an X. Before we had the board where it had 1s and 0s. It still exists, but in the UI we may change it so that it will display the X for us. Now let's go ahead and take a look at the code and where we made the changes. So here we have the code where it's going to ask the user for the board size and a row win. And notice that this code is pretty much identical to this code over here, except the integer value meaning different things. So you could actually go there and make this into a method and then pass the user's input and then convert it to an int. So we'll leave that to you so that you can actually create your own method. The other thing is for we kept this piece of code commented out, so in case you wanted to kind of test out the functionality of the DrawGameBoard and then go from there. But we commented out because we want the game to work correctly. So here we just made some update where we're using object initializer, where before we were just pressing the game engine .status equal to 0, not doing that anymore. And then we also have this user's input, and notice that now we have a -1. The reason is that when you saw the game, and let's say it's 12 and 5, when the user enters 1, this is actually index 0 of the multi-dimensional array, because arrays are indexed based from 0, right? So that's why we have to do -1, because whatever the user puts 1, it has to be a 0. If it's 2, it's a 1. We did the same thing for the column, and then on the make a move, we pass those information and it will work correctly. The next thing is that we made some updates to the game, draw in the game, as well as the print console. So let's kind of go over the DrawGameBoard. We're still calling the print console normally, and then we have a loop, and inside this loop we used to have just one print console, kind of like we had over here, with different values in it to display the columns. But now we need to account for something, so we have these spaces, and we check to see if the row, because we are iterating for the rows, and if it's greater than 8, and then we change the spaces to 2, and this accounts for the values that you saw in here, our game. So we had 2 digits. If the digit is single, then we put 2 spaces. If it's 2 digits, we have a single space. So that's what this is doing. But then why is the row greater than 8? And remember, this is index based 0, so we're actually saying if the row is greater than 9, meaning that the row is a 10. If it's 10, then it's 2 digits. You could also make this, if you had a really large board size, maybe go up to 100, and if your console does allow that, then you could put another if condition to make sure that this is less than 99 and greater than 8 or 10, or equal to 10. So you could have another case in there so that the spacing will be no spaces. So the next thing we do is we actually put the row with the number of spaces, and this is what accounts for those numeric value of rows. Then we are now printing the columns. We're grabbing the board and the current row and the current column and get the current value of the column. Then we have a empty char we set for default. If the current column is not equal to 0, then it must be a player, right? Then we call the getPlayer marker. So this method just brings an X or an O. So you could go here and update this to be whatever. So if it's player 2 versus player 1. Once we have that, then this value is no longer going to be a space, so that's when we're going to have the marker. Then we're going to enter the column, and then the column UI, which is the marker. If there was no marker, then it would just print out empty spaces. Then the last thing we do is, after the columns are printed, we need to close the column, so that's why we have this pipe here. Then everything else is normal going back. Then on the print console, what we did was the same thing. If the console, the increments are greater than 8, then we replace it from the 3 digits to 2 digits, right? This accounts for this values over here. So we are now having the values drawn right up to where the column starts. So that's what that is counting for. And this is pretty much all the changes we did. Hope that you guys enjoyed it. The reason we didn't write the code and we're not showing you all the instructions because the video is getting very long. So hopefully you enjoyed this video and give you some information about how to create a game that is in any row, and have fun. We'll see you in the next video tutorial.